So everybody talks about agents, and we do too. And I want to hear from Eitan why this is suddenly an endpoint topic, what the risks are, and then how Microsoft Defender can help you discover your agents, but then also help you stop potential attacks. Eitan, please introduce yourself.
Hi, thank you for inviting me. It's great to be here. My name is Eitan. I'm a PM in the Security for AI org, focusing on securing AI on endpoints.
Thank you for joining. And what I just mentioned, so why is this now suddenly an endpoint security topic?
Great question. Maybe I can zoom out a little bit. We have many discussions with organizations, and some of them see local AI agents as just a piece of software that is running on devices, and some of them see it as something that is unique, that needs to be treated a little bit differently. The way that we define local AI agents is basically an autonomous software system that runs on a device, or in some cases even a VM. It is using one or more large language models, which is already not a typical application, and it's pursuing some kind of a goal, right? It starts with a user prompt, and then it can take actions. It has direct access to everything that the user is working on. So the device, the files on the device, and systems that the user has access to. And the problem is that there is a combination where we have local AI agents that have a lot of agency. They can use tools. They have access to untrusted inputs like web pages or even emails. And there was someone that coined the term lethal trifecta, Simon Willison, like a year ago, something like that, and basically said, if you have this combination, then it's really risky. Why? Because unlike a standard piece of software where it's very predictable or almost predictable what the software is going to do, here we have unpredicted behavior that can change during the runtime, right? So the user can ask someone to do something that fetches information online from some kind of an untrusted source. That untrusted source can have malicious instructions and deviate the local agent behavior during runtime and start doing stuff that we don't want the agent to do. So I think this is the number one problem that we have. And when you look at the enterprise context, especially when it's super easy to install a lot of agentic applications today, they can do a lot. They have access to a lot of resources, and the security teams have little visibility, in some cases, no visibility at all, just at the process level in many cases.
Yeah. And we all love our agents because they're helping us so much in the day-to-day work. But of course, they come with all this risk. And I feel like, also for our customers, they need to really understand what kind of security mechanism they need to apply to securing AI. So I had an episode just recently about purview, right? So you want to make sure that there is no confidential content being entered or something. And then now we have the endpoint. So tell me a little bit more what we announced at Build, which is now available in preview for our customers, and how this maybe even complements other security for AI solutions.
At Build, a lot was announced, right? We had the Defender piece, but there was a broader picture of how Microsoft and Windows specifically really help run agents, local agents specifically, like sandbox environments and new guardrails and agent users. Our contribution to that release was in two areas. First one is discovering AI agents, and the second one is runtime protection of these agents. So if we zoom out again, when we talk to organizations, basically we have some kind of like 5 categories, right? We have discovery, governance, runtime protection, posture management, and threat detection, right? Even like the anomaly detection. And we really tackled two of the foundational pillars, at least that's how we see them, with discovery, where we can build on top of that security posture value and governance value, and runtime protection, which is the foundation to have like end user protection, proper experience, and also everything related to threat detection. So these are the capabilities that we released. We are working already on the next phases, but be happy to share these ones. They're pretty novel.
Yes. And I mean, I would love to see this in action. And then I already have a couple of questions because an agent is then on a device. On the device is a user. Maybe the agent uses a different user. How do I see all the different relationships between the agent and the other entities?
Got it. So maybe I can share a real example. We're in Microsoft Defender, right? I can even go back. This is the standard view. If you go to assets, there's a new blade, relatively new, called AA agents. And here we have all the managed platform agents, and we added a new tab called local agents. This is our small contribution here. We built a capability that extends Defender that is already on many organizations' devices. And what it does is basically using signals that we already get from the processes, from configuration files, and we correlate this information and determine that some kind of a process is an agent. And we discover close to 30 agents so far. And when we do the discovery process, we actually pull a lot of important and relevant information. Maybe I can give an example here of OpenClaw, right? So you can see that we extract properties on the agent itself, like the agent name, the vendor, the related process. This is a Node.js based application. And we also pull a few more properties. For example, if it's a trusted process, is it signed or not? Is it running in some kind of an auto-approve mode, which I'll be happy to expand. There is an identifier that you can use when you cross-reference the information with other telemetry tables. And then we also have the information about the device itself, right? So we already have, if you're using Defender for Endpoint, a list of all the devices, understanding of their exposure, their security risks, and you can actually see what device is hosting these local agents. And there's also the user context, the user that was running the application itself. And if we identify MCP servers, either local MCP servers or remote MCP servers, we also flag them here.
Wow. I just saw the MCP servers, which I think is also very interesting, that we identify what MCP servers this agent is talking to, I guess.
It's a little bit nuanced. We pulled MCP servers from the configuration files, so it's not MCPs that we can sign and say, hey, these were used. These are MCPs that can be used or in a way connected to the agent. So we look at the configuration files. We also look at the runtime, and we say, okay, this agent has like these remote MCPs configured and these local MCPs configured. And the cool thing about it is when we have remote MCPs configured, if other local agents or any other resources, it can be a container in the cloud or something else that are connected to it, and we have this mapping, you'll be able to see actually this MCP is being interacted with all of these identities, agents, and resources.
Okay, so you just mentioned there is, in your list, I think you had a lot of agents discovered here in your network. So what does an admin do with this now? Like, they probably don't go from one agent to the other and discover. So can they use some sort of queries to get a better understanding or a view of, I don't know, would we see any misusage or something? I mean, we are not yet in the protection phase. We are in discovery phase. But what do admins do with this information now?
So right now, with the mapping, and maybe I can expand a little bit more, right? We map each agent to the device, and we have the mapping to the identities and what the identities running the agents can access. This is already important information, exposure management information that can be used. So I can give an example, combination of a local agent, let's say Cloud Code, right, running in dangerously skip permissions, right, the equivalent of YOLO mode, running in elevated permissions by a user that has access to resources that the organization decided or determined they're critical, right? It can be a sensitive storage account, a key vault, a code repo that belongs to a production application. These are basically use cases that can be hunted today. Where we're aiming and where we're going right now is giving you a proper posture management experience with baked in risks and recommendations. Right now, it's not there yet. It's coming very soon. But what you can do so far is hunt for that. We push all the information that we discover to advanced hunting. And here is an example of the metadata that we send there. There is a new table called agents info that stores basically telemetry of both local and managed platform agents. And you can see here that you have all the information that we have in the inventory, in some cases even a little bit more. So for example, what type of agent, when we last discovered it, some properties about it, and you can see that we have a bunch of data here. Why is this important? Because now you can build queries that say, hey, I want to find all the local agents that I have that have risky configurations based on the way that the organization is determining them, and that have access somehow to reachable important resources. So this is something to keep an eye on.
Is this something that I can configure somewhere what I feel like is a risky configuration, or is this now something that I just enter in the query here?
Right now, we don't flag the risky configuration as risks. As I mentioned, it's not just posture management, but it is in the inventory. You can already see, is it running in elevated permissions? Is it running in auto-approve mode? Is it a trusted process? And you can use that information to query, this is an example, to query advanced hunting with the security graph that you already have. So we push the information into two places. One is the agents table that I just showed, and the second place is the exposure graph nodes and edges. This is a representation of the security graph. So if you look at the entire Microsoft Security Suite, many products do discovery, they extract posture and configuration information, and they push them to the map. We also model the relationships. These are the edges. And you can already use that information today to really discover, in this case, all the local agents that you have, which vendors they belong to, and which of them are risky by your definition. And you can really boil it down into, these are 3 risky agents that are also exposed. And if you want to go even a little bit deeper, this is an example of such a query.
I need to ask again, where do I define that is risky?
In advanced hunting. So you can say, for me, a combination of YOLO mode plus elevated permissions and ability to reach a critical storage account. In this example of OpenClaw, you can build a custom detection rule that discovers that and flags it immediately. So right now it is a manual process, can't sugarcoat it, but it is going to be baked in posture experience with risks. The early feedback that we got, if I go back to the inventory experience here, is that, hey, I'm a big organization. I have hundreds or even thousands of local agents, as well as managed platform agents. How do I know where to start, right? So this is where we're going to add the risk factors and all the indications of where you had security alerts and attack paths in the future. So it's all going to be here.
Now that we basically looked into advanced hunting and we discovered we have maybe 3 risky agents, can we also stop something and do something about it?
Good question. So first of all, I think for many organizations, when we started these discussions around this area of local agents, the visibility was the number one problem. And usually it comes with governance capability, right? So, okay, I discovered OpenClaw, although OpenClaw is, a tool that is very, very useful and you can build a bunch of stuff with that. With my organization, I don't have the proper guardrails for that. So I want to block it. I want to do something about it. Just in terms of the presence of the agentic application. So for that, you have Intune, and they also released a few relevant capabilities that can actually put guardrails in place. In the discovery use case, when it's typically security administrators that are consuming this information, the use case that we heard so far is, hey, I open a ticket to the developer, to the dev team lead, and ask them to uninstall something or run it in a different way. This is one area. The second one is proactively actually having guardrails on the device of the developer and stopping malicious behavior in real time, whether it's intentional or unintentional.
Yes, because I think this is very interesting because right now I see a lot of people just running after like, oh my goodness, AI is taking over and I need to react. So let's see what we can do to help them be a little bit more proactive here with runtime protection.
Yes, runtime protection. It's a big area. It's also a novel area.
And I want to mention here for runtime protection, everybody needs to have Microsoft Defender antivirus in active mode turned on so we can actually use it.
Yes, and we are working on removing that limitation as well, so that it's open to everyone. If you're not even using, Defender AV as the primary antivirus, but you're right. Something that I didn't mention about the discovery part is that it does require MDEP2 license. So if you have MDEP2 license today, I think you can just open the portal, assuming that you have the right permissions. You'll be able to see the inventory. You'll be able to explore the tables in advanced hunting.
I also didn't ask, and usually I always ask. So do you need to turn this on somewhere? I mean, if you have public preview features turned on, is there like a toggle that says discover AI agents, or will this just happen?
It will happen automatically.
Okay. Oh, I love that.
Yeah, so you don't need to turn anything on. Also, in terms of any like privacy or data governance concerns that company may have, this is just an extension of Defender. So think of all the signals that we already emit today. We extended that. We do most of the processing in the cloud. So nothing new or boundary crossing here.
Okay, so Ethan, before we actually hop onto the runtime protection, we talked about local agents, and I saw you had a lot in your list. But what are these agents? Well, like what is supported these days?
So we support, I think, like 4 or 5 different family types of local agents or autonomous agents. We have the typical, command line interface agents like Cloud Code CLI, GitHub Copilot CLI, Codex CLI. We have a bunch of those supported. And we also have desktop applications. So for example, Claude with Cowork and so on, the variations of ChatGPT desktop and Codex, and even the new GitHub Copilot application. And we also have environments such as Olama that are running on the machine or on the device of the developers in most cases, and everything that is related to clause, right? So OpenClaw, NemoClaw, NanoClaw, all these variations, these are all agent types that we are discovering today, and we're expanding it pretty fast. To be honest, like I looked at the list yesterday and it was already like 10 more new types that we added, but these are the big families.
Okay. What are the risky things about now that we want to protect in real time? Like, what can we do here?
Yeah, so we talked about at the beginning about the risks with local agents specifically, right? The way that they can use tools and they have access to sensitive information on the device and resources in the context of the user. The problem is the access to untrusted sources. So it can be an email, it can be a code repo, it can be usually web pages, even a small typo in some kind of a web page or something like that. That's in many cases can lead to an attacker-owned website that has malicious instructions. And the agent, in some cases, they can like identify it and stop, but in some cases, in many cases, they can't. And this is where we come in. So if I can give you an example, first of all, I do want to like show off about one thing, and that's how you enable it. If you look at it, enablement Right now it's part of previewing, but it's going out of previewing very, very soon. All you'll need to do is basically run this PowerShell commandlet that says, hey, I want AA agent protection enabled. And enabled means blocking it in real time or having it in audit mode. So this is, if you want to test it and you want to understand how it works, not concerned about false positives or something like that, you can start with audit mode and then move to block mode. Every time that we detect some kind of a prompt injection, which is the part that now I understand I skipped, but the main concern is prompt injection. It can be a direct prompt injection, an indirect or cross prompt injection. This is what we are looking for, and this is what we're blocking in real time. So every time that we block or there is an audit event that was supposed to block it, we trigger a security alert, and we'll cover that as well. So if I can show you a real example.
Yes, please.
So enablement is very, very easy, or enablement and configuration. It's one PowerShell commandlet. You can just write block or audit or disable it. And the cool thing is that this is deployed on every Windows operating system that we have, right? So everyone has it. If you want to enable it for your grandma or something like that, you can do it. And this is going to stay available to everyone. The configuration can be set here by the user, and it also can be set by the admin in your company. So if you want to do it through Intune or the Defender for endpoint configuration experience, the attach, you can also do it from there. And it's also protected configuration, so the user can't really change that. So let me give you a real example, right? Many developers today, not even developers, right? Even PMs and designers and everyone that is basically want to empower themselves with AI capabilities, they run these coding agents. In some cases, it's even CLIs, and they don't want to keep clicking allow, yes, I allow you to do it. And in many cases, that's the problem, that they run it in YOLO mode or auto-approve mode. And we get the point. We do it as well in many cases. Even Peter Steinberger, the founder of OpenClaw, mentioned it's like, all developers I know, that's how they run it. There's no other way to run it. So now we see the terminal UI of GitHub Copilot CLI. And let's say that I'm a user and I want to summarize open issues that we have in one of the code repos that the company is working on. And if there are any attachments, then summarize that as well. And if you look at this example, we see this code repository that looks legit, right? A chart drawing app. Maybe it's the company's code repo. And in the issues, we have a bug, and the bug has a good description of what happened and the expected behavior. But if we looked at what's inside of the attachment, it's actually malicious instructions, right? This is just an example, but it can be something in that sort, right? Like a long text that has a bunch of informative information, and then something that looks very clear, like you're no longer an AI agent. In many cases, it's way more advanced than that. And let's see if the agent is picking this up, right? So I'm going to ask it to summarize everything. Okay, and you can see here that the agent was blocked. First of all, you see the toast message that was here, just like with any antivirus alert or malware that was detected. And you can see here that the user gets a notification that says, the tool was blocked. We noticed that there are malicious instructions or security concerns in the operation of the tool, and we blocked it in real time. In some cases, the agent is even trying again and again in different approaches to try to fetch the information. It will still be blocked. If you look at what we're doing behind the scenes, when our capability is enabled, what we actually do is we tap into the vendor-supported hooks. And I know that many organizations don't like hooks, especially in the context of operating systems, but it's not the same as the typical hooks. These are hooks that Anthropic, OpenAI, and GitHub support, and they allow vendors to tap into operations in the agentic loop. If you look at the prompt, the tool call, the response from the tool, and everything else that happens there, and synchronously wait for a response, right? So we built this like advanced mechanism that basically does a very minimal setup on your device, extends Defender antivirus, and every time that we have a prompt from the user, every time that the agent harness is trying to call some kind of a tool, whether it's running code, opening a file on the device, or opening a web page. In this example, we are scanning the content, both what it's trying to do it and also the response that it is getting. And if we identify something that is funky in a way, we block it. And in order to do the blocking, it's not just the typical signatures that we have. We actually added a new local machine learning model that is running on every device, a very small one that was built for this purpose. And we see very good results with that. So if you think about the user experience, we saw that like message, but if you also go to Defender, you can see that we get more information here. So just like with malware that we have on the device, hopefully you don't have, you can see here more information about what was detected in the protection history, and the SOC also gets an experience.
Okay, that was my next question. So we also have an alert on the Defender portal for the SOC admin that there's something going, because it was a very short, quick AV message: toast, boom, gone. And for a user, maybe no clue what next. Yeah. Okay.
Yes, and I want to run a different example using Codex in this example and ask it to summarize a local file that I have on the device.
So whilst this is running, Eitan, so what happens after the block? Like, is it now? Oh, it blocks again. I see. Yeah.
Yes. So what happens after the block? First of all, we built it intentionally not to impede the productivity or the workflow of the person using the coding agent. We intentionally don't kill the entire process or the agent or lock the user. You know that we have these capabilities and we have disruption capabilities. In many cases, it's not with malicious intent behind it. In some cases it is, but we do want the user to keep working. So in most cases, they'll just need to open a new session and everything would work fine. We're also working with Entra on a new cool capability that hopefully we'll be able to share very soon, that also blocks it not just locally, but also in other places. That's the user experience. It's basically feedback in the agent itself and feedback in Defender. And if you think about the SOC persona or the SOC analyst, they get a typical security alert and security incident, right? If you go to incidents, just like with any incident that we have from Defender for Endpoint or any other product in the security suite, you can see here that we have new dedicated alerts that say, hey, this is a suspicious AI prompt injection with context about the device, context about the user that was running it. And you can also see it in the timeline of the device, just like with every Defender for Endpoint alert. You can take this information and already cross-reference it with the discovery information that we have about the configuration. You can use the Defender for Endpoint telemetry tables. So for example, process creation events, file access, network calls. And now you have a lot of context to actually understand, like, hey, this is a known coding agent that is accessing these files, and it was blocked because we detected prompt injection instructions as part of the process.
Yeah. And I know that we could probably talk forever more, Eitan, I know, but can we summarize for the people that would love to get started, like how should they start? Because I feel like turn it on, obviously, not the discovery, but the runtime protection needs to be turned on. And then make yourself familiar with the agents that are being used. Like, what are your suggestions here?
I think discovery is the first step. You don't need to do anything. You'll see it. If you see agents that are not familiar, or you want to put guardrails on them, right now we support 3 coding agents. It's for the runtime protection piece of it, Cloud Code CLI, GitHub Copilot CLI, and Codex CLI. Very, very soon we're extending it to OpenClaw as well, which is very cool. And we're also extending it to a very broader set of agents. So the best way to start is probably, it really depends how you want to run the proof of concept, right? You can just take a few devices and on your own set up everything. And we usually recommend start in audit mode, monitor the security alerts that are generated, play around with that, get more confidence, and then move to block mode. Personally, I think you can just start with block mode. We didn't see any spikes in false positives and so on. That's one approach. The second approach is just enable it on some kind of a user group from Intune or the MD attach. You can use partial scripts for that, and just run a POC on a set of customers. This is also what we're doing internally typically, and then we continue to a broader enablement or configuration.
Perfect. So, Ethan, thank you so much for being my experts on today's episode. I hope everyone out there is now checking the Microsoft Defender portal and how that new tab of AI agents looks like. And I hope then you come back and watch another episode. Thanks, everyone. Bye.
Thank you very much. Bye-bye.